Hello, everyone. How you can probably hear me. So I'm excited to be here, and hopefully you're excited after keynote. So I will try not to drop your excitement after my session. So I will start by introducing myself. So I am Eligijus Petrikonis, working as a lead solutions developer, but not just developing, but responsible for application from A to Z. So to test, for security and everything else what you can have in your mind. I have around 15 years experience in development, and I love to do rubber duck debugging. I have even my own rubber duck, even today. And I love to do a CrossFit just to clean my head out and avoid out-of-memory issues. So let's keep going. And let me show you something simple but powerful. It was just 3 seconds. How did it feel? Some of you started to think, have a speaker forgot what he wanted to say, maybe a slide doesn't work, but no, everything works as expected. And that's what our users could face nowadays when opening a website. And if it takes a long time to load, so user starts to wonder, should I refresh a page? Should I check a network or something else? But no, it's just a performance issue. So that's why it's important for our users. And now let's check what we have today in audience. So does anyone here have a performance tester in the team? Or performance team dedicated in your company? Okay. And how often do you test performance? Let's say yearly. Each time. Each release, okay. Someone else? No one, okay. And yeah, it's as expected, unfortunately. And hopefully it not happens in production, and hopefully it happens only in test environments. But if in case it happens in production, so maybe someone from your team or a manager would come to you and would ask, should we run a performance test to figure out is it a performance issue or not? So, but if you don't have it, how you can figure out it? So you can already start to understand why we need performance tests, but I will start with a short story. So when I joined my current team, we noticed that we have some performance tests, but not covering the most important flows. So we decided to implement. And the first reason was to understand our bottlenecks. And bottlenecks could be like a database, a broken cable in some room, or something else. You need to know what are your bottlenecks. Next one, non-functional requirements. Let's say you have 10 consumers, and one consumer says that you need to respond 100 requests per hour, and it's not a big number. But what about our 9 consumers? How you can know how many requests per second or per minute you can handle? And third, to notice a performance degradation. So we do each day or each week some changes and we deliver them. So just a simple if statement could affect very highly performance. So we need to monitor that. And of course, no one wants to be in this situation when everything is red, managers are calling you in the midnight if you have on call or something. So, and everyone wants to be in this situation. Unless, please raise a hand who wants to be in the previous situation. I guess no one. And I guess everyone would raise a hand in this situation, especially me. And today's developer hero tools, it's not a hammer and nail. It's okay to build, and we are developers, but to test the performance, first of all, we can use a GitHub, very known, and purpose to version a code, and for CI/CD, there is a workflows. And next one, Apache JMeter, open source, easy to use, easy to set up. And purpose, of course, it's a performance test tool. So there are a lot of types of performance, but in this session, I will cover these only. So first one, load, to get to understand your throughput and bottlenecks. Spike, drastic user increase. Capacity, upper limits of your application. Functional, that works as expected. Regression, that your expected throughput matching, comparing to threshold does not decrease. Then concurrency, simultaneous user interactions, and stress, upper limits, over the limits to see how your application reacts. And another question, has anyone here ever tried JMeter? And probably not. Oh, wow. So you tried, but you don't have performance tests. So it's strange. Okay, so let's go to default test structure first of all. And I prepared a lot of examples. So this is how it looks in JMeter. And first of all, when you will start from scratch, you will see a test plan item. And what you do with that, you put a name, and then you could define a variables, which will be used in lower levels. So in this example, I added URL, and value is build stuff event. So it's a homepage of this conference website. What we do next, in test plan, we can add threads, which actually like a container of users, how many of them to run. And there are mainly two which I recommend to use. First one is a setup, and another one is thread group. These ones differs like just that setup will run immediately as the first one, and another thread group will run once setup will be finalized. So let's cover the setup. And setup I use to warm up applications. So if you want to avoid cold start of your endpoints, so I recommend to do just a few calls to your endpoints to load a cache or something. And for this example, I added just a one user, and then ramp up to run that user immediately and just one time. What we have in that thread group, we add a sampler. And sampler is actually the call to the endpoint or whatever you want. There are a lot of type. In this session, I will add just a HTTP request, but you can even see a GraphQL if you want. What is that sampler? So this is HTTP request sampler. You put a name, and a name is important if you want to separate, and I recommend to separate warm-up calls and actual test calls, because otherwise in report they will be combined by name under same name. And what we add in basic tab, we select a request type, we put a variable defined previously, and that's all. And inside you can just make a calls, but we as well want to test that it's functioning correctly as you expect. And for that, you can add assertions. There are a lot of them, like a response or duration or hours. For this example, I added a response. So I expect response code to be equal to 200. When we have a single endpoint test, let's move it a bit. So this is that regular thread group. So I have put 10 users, run them at once, and just one time. So I expect 10 times to call that URL, which I put it in value. And then inside, it's the same HTTP request, but it has a different name without warm-up. So let's clean everything out and run it. And there are a lot of listeners which you can put and see when results combined or not combined. In this example, I put at view results tree, and in this view you can see each request how it went. And first of all, we see a warm-up, and then all 10 single ones. And then we have a summary report where the name is important. So warm-up, it's first one, and test actually a second one. So we can see here one's called warm-up, and the actual was made 10 calls. And from this, we can see that it's able to respond 4.8 requests per second at least. But it was just 10 users used. So I don't want to crash a build stuff homepage. Maybe not now. So for this session in purpose, I built a demo application as well. So let's just see what it is inside. So there are API endpoints. Later on, you will be able to see pure codes. There are API endpoints. So first one, speed test. So there are 3 API speed endpoints to test and a flow. So homepage, login, fetch user, fetch products, and logout. And we will test it a bit, these endpoints later on. Let's go back to presentation. And by knowing how to use a JMeter and to test like single endpoints, form it up, and etc., it's okay. But we need to know our limit, which we want to reach each time to compare each result. So this is a limit, how to get it. Let's go to JMeter back and open another example. And here it is. So it's very similar, test plan, but just using URL to my demo application. Warm up, 5 users, 1 time. 0 or 1 means same. Just immediately run all of them. In this example, it's different because I say stop test now. So if any warm-up call will fail, actually check max throughput won't be running. So it seems that some errors happens and warm-up cannot even be finalized correctly. And then we have warm-up, and it uses URL passed previously and uses API slow. Then we have response assertion 200, and this is actually thread group. My recommendation is to start from 200 users, ramp it up all of them at once, run infinitive loop, and for 3 minutes. From my experience, I see that these numbers, like around second minute, starts to show an errors if something wrong with your endpoint, or you don't, but the database indexes doesn't work or something. So, but it could be that your endpoint could handle even bigger number of users, so then you need to increase. But in this demo, let's decrease it because I know that this endpoint is slow, and just decrease on seconds to not over time. And then we have a test. So it's okay, I have a mistake in warm-up actually. API slow here. And yeah, HTTP request used calling API slow, response assertion as well as 200. Result 3 and summary report. Let's clean everything out and run. In the right top corner of JMeter, you can see that how long it already takes, how many threads was used, and warm-up threads, when it's finalized, all of them are cleaned out, and then actually thread groups are only showed. So we can see that it's running 40 users now, and from 40. So if you ramp up all of them, so we can see how it increases or decreases, depends how you ramp up them. It's still running, so warm-up have ended, and throughput was 45.6 per minute, and test is still running, and now it's around 50 per minute. Let's wait when it will be ended. Soon it will be. And it's a slow, so now it tries to wait for each response. And for some reason, it takes longer than it was previously, so. But maybe yeah, it's 13, 12, 11, so it's like counting new year, 9, 8, 7, 6, 5, 4, 3, 2, 1, done. Okay, so by this now we can see that it made 73 calls to that endpoint, and throughput was reached about 50.5 per minute. And I guess it's just a network issue because it should be much higher number. Okay, and by running several times this one, you can try by increase the number like 200. If you get some errors, then you decrease it and run it again until you don't have any errors in the results. Then I can back to the slides, and here is an example. It was running for 3 minutes a bit more, used 200 threads, made almost 50,000 calls to one endpoint, some errors, and throughput around 250 requests per second. So in this case, I would decrease a user number and run it again. And until I'm not getting any errors, then I will set up a test to use that same users, and throughput will be made like a threshold which I want to reach each time. During checking the limits, you can already start to monitor your graphs of CPU and memory, and you will start to notice, is it a CPU endpoint affected or more to memory, or maybe not at all. So maybe you don't need to use so many CPU or memory, and maybe you can save some money. And by this, we know how to test like a single endpoints, but users not working like just in one endpoint. They like opening a home page, clicking like a login, logging in, then seeing some products or some overview, and then log out. Then it's like a flow. So we as well need to test a flow. So it's possible to do that in JMeter as well. Let's open a first example. Let's toggle them around. And that's how in build stuff, let's say we have homepage build stuff. So you as a participant, you first of all, you would go to homepage, then to agenda probably, and then you will decide to buy a ticket. So it's like a flow. We can clean them out. And the flow endpoint, I made a 30 users to use, immediately them run, and one time only. So don't to crash a build stuff homepage. Let's run it. 30 users. And now it's already decreasing, so probably all of them ended. Yeah, so it's a warm-up, one call. And I need more space a bit. So first one, home, agenda tickets. So, okay, so home page reached 3.9, agenda 3.6, and tickets 3.8. So it probably something related mostly to agenda to improve. And then all of that flow results could increase immediately. So by that, you can figure out, is it your flow fast or not? And which endpoint is most slowest? Okay, so we can use like a JMeter in your laptop, but we as developers want to spend that local laptop CPU and memory to develop something, not to test. So we can provide or ask GitHub workflows to do that stuff for your purpose. And who here is familiar with GitHub workflows? I guess everyone? Okay, I saw hands and nods, so it's okay. So let's go and see how to run JMeter in GitHub workflow. And this is that example repo. It's a public in github.com, so later on you will be able to scan a QR code and to see that. So let's go to the source code. And under workflows, we have all JMeter YAML file. So who already know workflow, but some of them maybe not. So first of all, we define a name, how you want to name it. Then we specify triggers when you want to trigger them. I disabled on push on purpose. It was making too much deploys, but I left to dispatch manually and the schedule. So it runs each day. Actually, it just ended before starting the session. And then we specify jobs. There is only one job, run tests, and we specify where you want to run. I specify Ubuntu, and then steps. First of all, it's just like a best practice from my team. We like to clean everything out what is not related to us. Maybe someone left or runner was not cleaned out. When we set up a Java, JMeter requires a Java, but it's so simple to set up. You just set up and done. JMeter will take it by itself. And it's not mandatory to use the latest one. JMeter, I think, supports like from 6.17 or so, each much earlier versions as well. When we do a test curl to make just a one call to like a home page or ping endpoint, depends what you have, to see that your application is alive. Maybe not. So why you want to run a JMeter tests and occupy a runner, not for no purpose. And when we check out repository, because actual JMeter tests are stored, a JMeter test file is stored in the repo. When we are downloading a JMeter, and it's loading from external repository, from archive of Apache, and we store it in the run. When we display our files, just in case if something changes around, so we maybe need to tweak some paths to match it. And then we do actual magic. So we use a installed JMeter. We specify JMX file which was generated by using that application, and we specify that we want to store each endpoint call to test run JTL file, and as well in test report folder. And after that, we want to move this JTL file out of to test report folder. When we want to have ability to download a zipped statistics, if we need, and we again display files to see that zipped file appears in correct place, and all other files are as expected. And then we do a parsing of that JTL file to look up if any of endpoint was failed to call. If it failed, it means that something was broken, because we before have tested the limits. So by testing the limits, we expected no errors. That's why here we are expecting no errors to be. And if it is, means some endpoint have some struggles. And then we check if any of that failures was found. If yes, then we stop here. Otherwise, we're going to verify throughput against defined thresholds. So we go to test report folder, we find statistic.json file and open it, and then we define a threshold for each endpoint or a flow what you have tested. When we extract each throughput for each endpoint and assign to variable, and then we echo to the log to have ability to see from the logs each comparing a throughput and a threshold which was desired to match. And then we validate the performance. So if all throughputs was reached or exceeded a threshold, so when we say throughputs are greater than thresholds, and it's okay, as you expect. But if not, then we say some throughputs are not. And you need to check statistics from above. So I have 2 examples. So this is a successful. So let's first of all let's go to run JMeter script part. And here you can see like each 30 seconds logged statistics. One line is saying overall statistics, what is going on, and another saying for specific 30 seconds of endpoint call, if you want to see how many errors and when errors appeared, or have all users was used. And after that, let's go and see verify throughput. So in this example, throughput was all throughputs was greater, so it's success. In another, it's a red, and then it's saying that not greater. So we need to check why it happened. And okay, we can as well. I have downloaded previously, so you can, as I showed, we have a zipped file as well. So after downloading that zipped and extracting, you can open index.html. And from that, you can see some statistics from this view. And there is a statistics overview table here. So then you can check a throughput as well in this one. And we can see a warm-up requests and the regular ones. But how actually that test looks like? And here it is. So we have a warm-up, or let's start from the top. So URL, it's pointing to that demo application. When we have a warm-up, it uses 5 users just for one time. And inside I put it all endpoints which will be used in further testing. So it's testing all endpoints to warm up. And then we have each thread group to test like a single ones. And in the end, we have a flow, a homepage, login, user, products, logout. And it's important that, as I mentioned, when setup thread group ends, it will immediately launches all other thread groups. In this example, if you want to test only like a single endpoint in the sequence, you need to start to use a delay. So you specify how long you want to run, and you put a delay. So for example, the slow single have just a 5 seconds delay from the startup, and it runs for 2 minutes. Medium is delayed much longer. User is a single, much more longer delayed, and user flow, the latest one to run. So, and you are separating your tests.
Sorry, so you don't wait for each other to finish, you have to sort of manually set up.
Yeah. And recommendation is from JMeter, not from myself, that to have just a one listener summary report when you will run in command line, like in GitHub. View results tree to see each endpoint call is required not to be enabled because it takes more resources to accumulate. So that's how it looks all example. Let's go back to here. Okay. So we know how to test, and results we can check each time after GitHub workflow run, but we as well want to see some trend. Is it going slower, faster, or what is happening? For that reason, we use Excel. Yeah, it's Excel, but trying to find another approach, but not yet. So we have like a template. In the top row, we specify threads just for our purpose. Otherwise, you need to go to JMeter test and see how many users you use for that. Then next is a thresholds which you desired to reach, and then a statistics. So each column represents endpoint or a flow, and then each row represents attempt of test. So in the column B, if we have a status, so if it's a red, means that some cell have not reached threshold. And if it's green, so all of them reached or exceeded. And lower, we have an average and the lowest values. And by that, you can start to figure out, is it going worse or better? So let's go to key learnings. And if you remember, I started with a short story when I joined the team. We implemented the performance tests. And after implementing, we noticed that we started to get more and more data on our database. And it's as expected. But our performance test as well from that Excel file showed that our endpoints starting to be slower and slower and slower. In the beginning, it was like 10 requests per second able to answer. In the end, it was like 2 or 3 requests per second. And that endpoints are sensitive. So 10 was pretty okay, 2 or 3 not. So we decided to figure out what is happening. So we found that we need to improve indexes for database and some relations between tables. We did that, and what we reached now, that endpoint's able to answer between 70 to 80 requests per second. So it's not even 10 now it's 70, 80. So it's a big improvement. And another story, we have like one consumer which implemented the duration expectation that we need to respond in half of a second each time. And consumers complained that we are not responding mostly times. And we had that test to test that we are responding 200, but not a duration. We had a duration assertion, and we found, no, we are not reaching. We usually responding around a second. So we need to find what is happening. And we improved. Again, it was mostly database related. And now it's responding like 10, 20, between 10 and 20 milliseconds. So it's as well key learning. And like to summarize key learnings, so database already mentioned, and it could be very big bottleneck for you. So consider to improve it and not save too much time to improve it. If you have time, improve it, because it could be very big bottleneck. Then Kafka. Our main data goes via Kafka mainly, and we use global tables in most important data applications. And those applications showed that able to answer like 3,000 or 4,000 requests per second. We even can scale them up to respond even more requests, but not needed now. So consider to use a Kafka. Then production resources. By testing, you will see that if you need to use all of that resources or not, but as well to have understanding, will that endpoints will work as, to expect to work same in production, you need to compare and set up same resources in test environment, which will be used for performance tests. Network firewall, yeah, unfortunately it happens. Network is not so stable, and it could affect your results. We found like a slot when it's less disturbances for us, and we're running weekly them or that performance tests. And firewall, you never know when some firewall team will add some additional rule, and your endpoints will start to crash. So, or your performance test will be blocked. And warm up, as already mentioned, it's important, like if you go to the gym, you first of all warm up yourself, and then you do a performance. So try to avoid some crashes. And let's go to the summary more. So I want to invite you to know your application performance Why? First, notice the changes. Is it going better or worse? Weak spots like a database or some network, it could be. And resource management to save money, but as well you will understand how many CPU and memory, maybe you need more. And by that, I want to say thank you, and this is a QR code to that GitHub repository. Everything what I showed today, it's in that repository. So thank you.